So I'd like to introduce the next speaker. And so our next speaker is David Buzz, and talking about the cloud and configurator. So he's got like a double talk in one, and he's going to have cameos from Nick. We had the problem from Nick Cruzan. He had an issue yesterday with his Zoom setup, and he's now fixed that. So we're going to have like a triple talk in one. So over to you, Buzz.
Morning all, evening all, wherever you are. How you doing? Let me just share the right screen and we can get going. We can all see that okay? Testing.
Yep,
3, 2,
all
1.
good.
Yep, great. All right. This is my update for the last year, mostly focused on cloud and configurator, which are things you probably have sort of heard of, seen, but may not have paid a lot of attention to. So they're both new projects. AP Cloud is only 2 months old. RG Configurator was sort of started 11 months ago, May last year. And they're web technologies that are sort of in part of the ecosystem, but not really, in the autopilot itself. Telling you about them, they're based around these sorts of tech. Node.js, which anyone who's used web tech these days knows that Node is sort of the server-side JavaScript. The configurator is actually sort of packaged with a piece of software called nw.js, which is actually a combination of Node and Google Chrome extensions. RG Configurator, what is it? It's a configuration tool for RG Pilot. So it's designed for new users to get people configuring their autopilot from the I've just received a board to I have firmware to I want to set up the right frame type and put the right vehicle on and get the right outputs, and to be as easy as we can possibly make it, and to be written using modern web technology. And it's a fork of the iNav configurator, which is a fork of the Beautifulite configurator, which I've got some shots of below. But that's basically what it's about. And now I want to give you guys a quick demo of it before I go on to the next slide. So if you just give me 5 seconds to start up a configurator. Magic happening on the other screen. Insert software here. Are you seeing that now?
Yep, no problem. Yep, good.
Great, great. People are still there. So this is a software configurator, and I'm going to plug it into a Pixhawk I have sitting here on the bench, and I'm going to connect to it. And what we've done basically at this point is it's connected to the serial device. It's said, hey, that looks like an airplane. And it's decided that because it's probably an airplane, that on the setup screen, we can have pre-arm checks that have passed or haven't passed. We can have battery information. We can have little 3D visualizations, and we can look through different sorts of airplane that you might be likely to see. So, for example, is it a Bixler style airplane? If I just grab the Pixhawk, by the way, and tip the Pixhawk, it tells you that the visualizations move. What sort of aircraft are you thinking about putting on this? Are you putting a quad plane, for example? Is it one of these lovely, this is the Alti, I believe, is it? Or maybe you're thinking about doing a bit of a classic aeroplane, something like like this one, lovely flaps style. Gives users good knowledge about the sorts of setups that they can do. This is a CUAV TVBS. And we've pulled these 3D models from publicly available information on And the idea is to give users a, hey, this is the sort of plane I've got. All right, so this is mostly just about a little bit of interactivity and letting people play with the flight controller. But the next screen is about configuring it. And what we have here is all of the usual calibrations that you would do in Mission Planner. So we can calibrate the accelerometer, for example. I'm going to do that while we're here. And it says place the vehicle level, and what behind the scenes, I'm now putting the autopilot on the left side and putting it on the right side and putting it nose down and nose up. So you're not seeing me waving the autopilot around, but it's done an Excel cal. We can do some compass cals. Let's try a 3D compass cal. It has a little bar graph down the bottom here that sort of shows the completeness state of the compass cal. And if it succeeds basically when all those bars go to the top. So I'm furiously waving the autopilot around, hoping that the compass cal will complete. There we go. And I'm going to accept the compass cal, and it shows us the compass cal offsets we've just done. A new feature that I've just sort of been squeezing in this is new as of the last 3 days, as we can actually do an RC cal in here as well. And I've faked some transmitter inputs right now, but the idea is that users can move their sticks around and it shows up on the 2 double crosses, just like they move their sticks around in Mission Planner. And when they're done, they click done. That doesn't quite push anything up to the autopilot just yet, but it's only a couple of days old. So from here, you've basically done sort of the usual calibrations, or at least enough for it to be meaningful. We can go on to the next tab where we can decide what sort of layout we want our airplane to be. Now, obviously, it's decided that you're an airplane, but we could change this to a multi-rotor, and we can look at the different multi-rotor types in here. But for right now, we are actually an airplane, so let's stay on there. And we want to have a flying wing with differential thrust. It's going to sort of suggest this motor layout. Or maybe we want to have a quad plane with all of things. Or we want to have a V-tail with just with individuals. There's a few sort of standard templates of suggested layouts here. And each of these is helped along by a little diagram. But for the purposes of this one, let's pick a quad plane with no tilting props. And I show that suggested layout. And it comes down here and helps the user to understand what the servo functions have to be for that particular configuration. So it said you're going to use 8 servos. We're going to have the servo functions here. We're going to have motor min-max trims, which those populate through the RC cal on the other tab that I haven't completed. But you get the idea that we can reverse these things, or we can choose our own adventure, and we can add a new servo layout, and we can put our own. Maybe we need a gimbal, or maybe we need differential spoilers, and we can choose our own adventure rather than using the suggested layout. But if we're going to go with the suggested layout, we can then go save the servo layout now, and up the top here in green, you can see it's sending instructions to the autopilot that this is our servo configuration. So this is all functional.
Interesting, Buzz, that it offers like plane, copter, rover, etc. At this point, you're already connected to a vehicle. Could it just only show that the one if you're connected, you've got plane firmware loaded at this point?
Yeah, that's right.
You can't actually do.
In fact, if you scroll up to the very top, the very first thing it says is you appear to be connected to a plane. So it does certainly know that.
So it has pre-selected, but you can override that.
And yeah, that's right. So
that was very
this little setup here is, so if you choose your own adventure and don't leave this on the defaults, then it might do strange results at the moment. But it automatically populates this first drop down, which is actually on a few tabs. So it's in here and it automatically chooses this one for you. So I might even be able to get rid of that box and just hide it from the user and just use this second sort of suggested layouts. But this is how it is right now, and I thought I'd just show you guys that we can actually look at the quad plane. We've got the little graphics, and this might not be the optimal layout, but it's what I've chosen right now, and these are basically sort of templates. So and yeah, it does actually set the it says, hey, you're a quad plane now, and it's gone off and it's set the Q frame class and the Q tilt type and a few other defaults for them behind the scenes. I'm showing the params in here because it sort of gives you guys an idea of the fact that it is actually connected to the Mavlink stream and talking a few things behind the scene that need to be set up. All right, so we're basically working our way down through these tabs. This is sort of the setup process. And in outputs, this is a little bit incomplete at this point because it's not entirely there, but the idea is that it shows you the servos as they move around, and it allows you to change a few things like maybe one shot, D shot, and set some refresh rates. But I might even get rid of some of this. So it has the usual parameters lists for the people who want to go in there and configure the params. We can pull the params from the vehicle again, although it's already done that, obviously. And we can change an arbitrary param. Let's just change this to a different number, and you can see it lets you write that param. So we've got full parameter reading and writing, and we've got a bit of a map.
Buzz,
yes?
Can I suggest on the parameters list you add another tab with the favorites parameters that the user could select which parameters are most used and keep it there?
Pull requests welcome.
Okay, thanks. Sorry.
So yes, there's a lot of things in here that are not complete yet, but we're getting there. So we've got a Mavlink inspector that shows you sort of the situational awareness, and it shows we've got a real Mavlink stream coming in here that's being managed. So there's some tuning stuff that goes in, and right now this is pretty much stock from iNav. So none of these magic voodoo settings have been integrated at this point. This is just sort of showing what the potential for what could be if we wanted to have some sort of advanced screen. So if you kind of just ignore that screen for the time being, and we'll just move on. So the receiver in here, if you move your receiver around a bit, you can see I've got some fake receiver data feeding into this particular one right now. But it allows the user again to see the receiver and to potentially change receiver types. So again, we're working on implementing the back-end Mavlink for some of these things. Right, GPS is a map, and it shows you, right now I don't have a actual like GPS lock because my GPS is inside behind a tinted window, but you get the idea. And the part of this that I'm probably proudest of is the fact that the mission control tab is fully functional. So we can actually come in here and we can put mission like waypoints in here, and we can send that mission to the flight controller. So we can also look at individual waypoints, and we can decide to change them. We want to make this first one a takeoff, and we want to make the last one a landing, for example. You can do that sort of thing. So we've just got the ability to save it to the flight controller. We can also go read from the flight controller, and this is basically clearing what you have, talking to the flight controller and pulling the flight controller information here. And you can show that we've got some waypoints in here that may or may not be entirely accurate. But it's it's the GUI works, the Mavlink backend to it works, the reading and writing to the autopilot works. We've got the ability to edit waypoints. We've got some return to home capabilities that's a little bit sort of it's iNavish, but we can at least edit and send stuff. And the sensor screen lets us see, I'm going to pick up the autopilot now and wave it around, and you can get the idea that things are happening here. And it's graphing the stuff across the top. So that's basically where we are at with the user experience of it. The only other thing I want to show you guys is the bit that happens before all of this. So when a user first comes in here, before they even press connect, there is actually a firmware flasher screen. So I probably should have showed you this first, because that's the very first thing a user will do before they even try to press connect. But we can go in here and we can say it's an RG plane and it's a Pixhawk 1 or something, FMU V2. Let's choose that. And we can say, okay, so let's choose the latest 4.3, and it's an APJ file. That's great. And we could then go load firmware online, and it says, show me the information about that. And it actually has gone and fetched that particular APJ from the internet, and it's showing us information about what's in it down here. I could then flash the firmware by pressing the making sure the flash on connect, and then unplug it and replug it. But you guys don't need to see me flash a Pixel from here, do you? You kind of get the idea. And it has, it's just sort of a little bit slower to flash, but you guys get the idea. And it can also send users off to the wiki to get help. So, all right, so that's basically RG Configurator as it stands right now. It's not a complete solution, and it hasn't had its first release, but it is getting there. I'm pretty happy with the progress we've made. Every time I work on it, it gets better. And it didn't have the calibration, the RC calibration in there as of a few days ago, but now it does. So, all right, let's carry on back to the slideshow, and we're going to go to the next one, which talks about AP Cloud, which is all thanks to Randy. He said, I would love to have X, Y, Z, and I said, how hard can it be?
Very much.
So he wanted a fleet management solution mostly for his boats, but it's designed to do log analysis, log uploads, to fetch information about the autopilot. Helps people understand what firmware they have deployed and what versions, and how many of them, and to try to take some of the tedium out of managing big files. And it's web-based tech, and it's Randy's fault. So it's not a ground station. It maybe should have been called AP Fleet or AP Fleet Backend, but right now it's called AP Cloud. And that's a little bit about what AP Cloud is. And now I'm going to give you guys a demo. Just have to press some magic buttons.
So Buzz, this is our open source version of what, for instance, AirData is doing, right? The AP Cloud.
So, yeah. All right, so this is an AP Cloud instance I have running. It's just sitting here, running in the back end. You can run it on a laptop, or you can run it as Randy's done in an AWS instance, or you can run it anywhere that's convenient, that you have enough connectivity to your drones to be able to, for the backend node service to be able to communicate with the drones. And there's two different ways of doing that. The service can actually use SSH. So if your drone happens to be sitting right next to your instance, like it is for me here, I have a drone that this is going off, and it's actually SSHs into it periodically and says, hey drone, do you have logs? And it updates the logs, pulls them from the drone, and the magic has happened. The other way to get the logs into the drone is for the drone to SCP them up to the instance, and Randy's demonstrated that quite successfully by having the drone using a companion computer, and for the companion computer to actually send the logs up to the server via SCP. So what we have now is in this demo is a few drones. So drone 1 then shows you this particular drone is an RG plane. It's a very, very old RG plane because I found some logs that were PX4 based, and I thought it would be nice to make sure that that worked. But it shows you the version, and it shows you the Git hash, and it shows you the total time in air and distance traveled in that log. And whether or not there was any mission involved, whether or not there was any fail-safe events, and it also has the ability for the user to get to the log file directly as well. They just click the log on, and it will just download it straight away. So sort of situational awareness on this pretty clearly shows you that these things should have been upgraded, but they haven't been. And that was drone 1. Drone 2 is a little bit of a scattering of things. I've actually just dropped a bunch of logs I had in here for testing. I've got some Chibios-based RG plane running on Q Blacks, and I happen to have a RG copter in here. So this is some of the work I did for RF design, but it's got time traveled, distance traveled, and you can see the RC protocol. So it says, hey, this particular one is using PPM, which means it's not as safe as SBus. So maybe that one needs to be, have its configuration changed. You can also see whether or not that particular operation had a fence on board. And down the bottom here, we've got this particular plane, which was running PX4. It had a fail-safe event. So that's sort of one where you go, hey, that was a really easy one to look at. It's bright red. I can click on it, and I can get the log and find out more. So drone 3 was my test to make sure this particular the AP Cloud could handle more logs than you should throw at it. So I've thrown hundreds and hundreds and hundreds of them at it, 600 at this point, and it's just sort of everything I've ever collected duplicated in here, and it goes on for a very, very long time. But the point is, it processed all of them, and it gives me situational awareness on all of them, and I just had to copy them into a folder and then leave it to it and come back when it was done. And this last one, drone 4, is actually Randy's boat. So Randy has Chibios running on a Q Orange. Here's the serial number of this, and there was no fail safes and no sort of scary events in here that it's sort of obviously highlighted, but perhaps he has something in there that he wants to add to it. But I thought I'd put that one in there because these are also some fairly large logs, and Randy was kind enough to try it out. So there we go, running 4.2-dev at the time. It also gives us a few other things, like you can look at all the serials that were involved, and you can say, hey, this particular serial has been flown 100 times, irrespective of which drone it was in, because sometimes these cubes move around. And you can see that most of the work in here looks like it was done with Cube Blacks rather than Cube Oranges. So maybe we need to do some upgrades on some of those drones if they're still operating. There we go, that's the demo. Any questions about that demo? Tumbleweeds.
We had a couple questions. Let's see. Let me go back to them about the configurator.
Oh yeah, sure.
Yeah. Where were they? Oh, how do you manage new parameters as in a new firmware version with added parameters, or is it dynamically updated?
The parameters list is dynamic. It fetches everything in the usual way Mission Planner does. It doesn't have a lot of metadata about the parameters right now like Mission Planner does. So it doesn't tell you sort of meaningful values or mins and maxes, but it lets you read and write them at the moment.
Okie doke. And then we got 2 more, I think. Any plans to, I know it's a work in progress, to add PID mask, enabled live tuning graphs?
So what I want for it to start with is to be the simplest possible workflow we can make for new users. So to give them help where necessary. In fact, you saw that I had an embedded video on the page, and I have lots of graphics and big bright buttons that are sort of change color as you click on them. So that's the main sort of first pass of this, is to make it useful to new users. It also is helpful because it's familiar to people who come from the iNav and Betaflight sort of ecosystem. It's going to feel very similar. But once we go from there, making it more fully featured and being able to do more things and take more mission planner ideas and bring them into it, because effectively this is sort of a subset of what Mission Planner does, just done in web tech. So that's
one more from me actually, because we were getting asked on the Discord about where can someone grab it, and then I went to the page release. You had a release page, so when you're going to get some releases on and auto build it, so people can just download for the platform.
So right now we're focusing on dev. It's not neither of them is really release ready. The AP Cloud sort of does everything I described, but it doesn't have any sort of security around it. So if you run it on your local box, you're not really concerned about it. But if you were going to put it in an AWS instance, you kind of want to have password protection and a few other things. So AP Cloud, the other thing it doesn't do right now, which we'd love for it to do, is to be able to automatically update the firmware on all the drones that it can find information about. And I think those two things are achievable, but the security one needs to happen before we sort of do a release. As far as the configurator is concerned, it needs to not do stupid things. And there are a few pages that are just not tied in correctly or just shouldn't be there. Maybe the advanced tuning page should go away entirely at this point. But right now, the things that do work well is the mission setup and the initial sort of visualizations and the 3D views and the RC and all the calibrations. So I'm pretty pleased with how that's going. So the configurator, I think, will probably have its first real sort of user release maybe in the next 6 months, because it's a huge application.
Buzz, and perhaps a bit off reach. From that project that was presented last year that came from Intel, the OMC, are you planning to bring things from that OMC to Configurator?
I believe OMC was written in a lot of Java, wasn't it?
Yeah.
I don't think it's actually based on web tech at all. JavaScript and Java are not the same thing. So. But we can certainly steal ideas. I've stolen ideas from Mission Planner to bring them into here, like how we should do the calibrations and what the user experience might look like. We can learn from what Mission Planner does well and try to take some of those things. So basically, just letting you guys know what the state we're at with these. They're both works in progress. They're both web tech. They're both brand new. And we'd love to have more people involved. So that's the end of my talk.
Hey, David, I have a question for you. I was wondering if you have heard or have seen the video from Powell Swaglowski about he's now an Archibald developer.
Yes, I did actually see his video. That was a great video.
Yeah.
Because we forked iNav Configurator, which forked Betaflight, and they're all friendly. When our GitHub repo, when we first forked it, showed him as the top contributor. I don't think that's the case any longer, because I've done about 1,000 commits since then. But it was pretty fun. I've also spoken to Pavel a couple of times, and he's pretty chuffed. So. Any other questions? Any other thoughts? Otherwise, we can go on to Nick.